Good morning, ladies and gentlemen. Welcome to the Smart Manufacturing Week organized by Lux Innovation. Today's webinar is about successful smart manufacturing transformations and use cases. My name is Caroline Muller, and I am manager of the Materials and Manufacturing Cluster at Lux Innovation. And I will have the pleasure to moderate this webinar with my colleague Anthony Auert, manager of the Automobility Cluster. Good morning, Anthony. How are you doing today?
Good morning, Caroline. Thanks for the introduction. Good morning, everyone. A warm welcome from my side as well. I'm glad to see that this webinar is followed by a large audience, which is a good sign that the program we have put together today is drawing a lot of attention.
Thank you, Anthony. So today we'll hear 6 testimonials and speakers, so industrial speakers, and we'll have some presentations also about European fundings. So the first speaker we'll have on stage is Mr. Cristian Paun from Dupont Nemours. Good morning, Cristian.
Good morning. Thanks for the invite.
Then we'll hear Mr. Mark Offenburger from Avery Dennison. Good morning, Mark. He will be followed by Roberto di Gori from Ampacet.
Good morning, Caroline. Thanks for the invite, and good morning, everybody. Thanks for joining.
And then we'll welcome Professor Olga Rose from the University of Luxembourg. Good morning,
Hello,
Olga.
good morning. Good morning. Yeah, welcome everybody, and many thanks for the invitation to speak today.
It's a pleasure. And then we'll move to European fundings, and we hear Giles Brandon from Intelligentsia Consultants.
Good morning, Caroline. Good morning, everybody. Thank you very much for this invitation. I look forward to presenting shortly.
Thank you. And we'll conclude with our new colleague, Francisco Melo from Lux Innovation. Welcome, Francisco.
Hello, thanks for the opportunity. Good morning, everyone, and looking forward to interacting with you all.
Thank you. So you'll have the possibility to ask questions to all the speakers, and we'll spend 2 minutes at the end of each presentation to answer the questions. So please do not hesitate to chat, to ask questions. It should be an interactive session. So as you've seen, we're using a very polyvalent digital platform with many functionalities. And my dear colleague Anthony will now briefly present you this tool.
Thank you, Caroline. So before we get into the subject, a few information about the webinar platform. If you look on the right side of your screen, so there on the right side, you will find 5 little icons that you can click. With the first one on the top, you can chat with all people that are connected to the webinar. The second one gives you the possibility to ask questions you might have, or like a question asked by other participants. As Caroline said, we have planned around 2 to 3 minutes for Q&A with the speaker at the end of the sessions. So don't hesitate to ask a question by using this tool. Just below is the section for polls here. If you click on it, you will see that there are already 2 little ice-breaking polls. Please try to vote to train yourself with the tool. We will add additional questions during the webinar and would be happy to get your feedback. The fourth icon gives you an overview of the people that are attending the webinar. And finally, under the last icon here, you can post a file you would like to share with the audience. Going to the next slide. Here it is. After the webinar, the virtual lobby offers you the possibility to network and chat live with participating companies. You can join group discussion, but you can also contact specific people for private networking. That's what you see here on the lower part. If you wish, you can get as well, you can visit as well the virtual booth. That's what you see here, where you have a various service provider that you can see on the top right here. We encourage you to make use of those functionalities as we want this session to be as interactive as possible. The replay video of each webinar will be available online as well for your convenience. But now, let's move to the first speaker. I'd like to introduce Mr. Cristian Paun, Global Digital Strategic Chief Digital Officer at Dupont de Nemours. He will talk about unleashing the power of digital in the manufacturing world. So first I need to stop sharing my presentation. Here you are.
Thank you
Mr.
very
Paun,
much.
the floor is yours, please.
Thank you very much. Let me also bring my slides up and try to share a little bit about a couple of use cases that I believe are very much useful in the manufacturing and how you could unleash the power of digital in your company too. So we could all see that manufacturing performance has become more critical to deliver growth to the business, but there are also several challenges that we could see. Not going to read them all, but I would emphasize definitely the regulatory complexity, and especially if you are in certain areas like in the chemical industry, for instance. I would emphasize a lot the underperforming operation, and I'm sure that in many companies in the manufacturing space, you have probably equipments that are probably old and that you're trying to make sure that are delivering at their best performance. I'm sure there is a pressure to reduce costs, right? Especially since last year with COVID. But what I would highlight as well is that the number 5 is the poor use and availability of data and advanced analytics. And that's an area that I'll talk as well a bit more in the next slides to see how you can unlock the digital. You could see that many companies, and we have here a bit of phases, are going through different phases, and as well they are trying to use traditional manufacturing excellence programs, which in essence it's not bad at all, but all these, the underperforming operation, fragmented approach to the implementation, the lack of standardization. There are a lot of best practices that are embedded in our day-to-day work, but are not all standardized globally, especially for very big companies. All of those are actually showing to us that there has to be more in order for a company to become more successful and to increase the performance of their assets. And how do you do this? What we discover is that it's actually not only looking at the OT part or the operational excellence part or the IT part. All those are important, but combining actually all these three, right? So you have to have for sure in your company different Six Sigma program, Kaizen, reliability engineering programs. All are very much good. You have to have most likely OPEX programs, right, that are meant to reduce your energy consumption, yield loss consumption, right? Overhead in savings. But adding to this, the third dimension, the technology part, where you can embed IoT, AI, robotics, smart sensor, big data and analytics, even blockchain, depending on the use cases you'll see later. This is actually what is going to significantly drive performance in the manufacturing space. And I'll try to give a couple of examples. We call it the smart factory, and how we could believe our factory can be much smarter in the future by combining these 4 dimensions. And I will focus, of course, on the digital part where you could see IoT, AI, machine learning, such use cases that we have applied. So I'll take a couple of use cases that I would like to share with you. If I concentrate first on the smart maintenance management, we have here use cases which is predictive maintenance. And what we have done basically is to try to monitor in real time the performance of our equipments against different type of parameters and sensors that we have. And then with the machine learning algorithm, we were able to understand much better what type of conditions we have and when this algorithm can predict that we may have an issue. Now imagine that in the manufacturing world, if you have a shutdown of your plant, it can be sometimes even $1 million per day to have your plant shut it down, right? Just for maintenance. Now, if you are able to reduce from 4 times per year this maintenance to only 1 or 2 times, you can imagine that this is millions that is saving you. So with all those smart sensor and the machine learning algorithm transmitting when a certain equipment is highly likely to fail, this helps you reduce dramatically the number of unplanned maintenance downtime and thus reduce your cost. Another one that I can highlight is regarding intelligence maintenance. So by using augmented reality. So we're trying to see how you can use augmented reality for several things. One is how do you repair some stuff? Now, it has been, for instance, a challenge to attract talents in the manufacturing space, and we could see that having people to read, especially young generation, files like that, or Word with hundreds of pages, was not necessarily something that they were looking for. But when they have a tablet, and you can see here with augmented reality, where they can use and see in more or less real pictures and videos how to repair certain equipments, that is something that was more accurate, faster to get people certified, and of course much better perceived by our young new generation attending. And the same, we were able to use this, for instance, even for remote service. Imagine that you have some people that are extremely talented. We had, for instance, cases with people located in US or in Europe, and that were supposed to troubleshoot for other plants in Asia or across the globe, wherever in Africa. And we were able to use through this AR solution, virtual reality solution, we were able to use this type of solution to help debug without traveling. And especially with COVID, that was absolutely essential for us, and reduce not only the traveling cost, but as well much faster in the reaction when you have issues, right? Because you don't have to wait a couple of days for that person to arrive. Smart quality management. So the same we try to use in order to improve the quality of our solutions. Dupont, for instance, is producing Tyvek, which is critical and was critical for personal protection, and especially with COVID. So how you make sure, for instance, for the pharmaceutical and healthcare system, that your equipments are 100% accurate, right? So what we did, it was a combination of getting all this data that we gather from quality system and put it into a machine learning algorithm, plus getting some video cameras that can see real time how the equipment, for instance, is being produced, and then all this mapped into a machine learning algorithm could let us know if there are defects, and then you would be able in real time to stop, for instance, the machine and cut those defects and then restart. So thus reducing again the number of defects, and thus the number of losses for the company. Smart energy management. The same, we were able to try to reduce our energy consumption by using the same analytics, and able to understand much better when do you start certain machine, and as well especially you have different shifts, right? So some machine you can run 24/7, some you can start in shift 1, stop in shift 2, start again in shift 3. How do you basically do all this in order to reduce your energy consumption? And putting all this into a machine learning algorithm was something that helped us understand much better about the trend of the energy and how you can reduce it. Another part, smart compliance management, right? So this is related with the quality part, but let's say it's not only quality of the equipment, but then you need to report, for instance, to European Commission and other such bodies, the quality of your equipment, and as well the fact that you don't have leakages of certain chemicals, for instance, and you are in those limits. And the same, getting all this data from quality system, from operations scorecard, metrics from different reports, gathering all this into a big data was actually helping us to understand much better. And you could see here where we may have different trends and where we may have issues, in such a way that we are able to take some measures in time. We are able to develop even some dashboards that you can have self-services, for instance, for different departments, and they can analyze depending on what quality wants to see, what operation wants to see, what manufacturing wants to see. So all these could definitely give you a very good perspective on how you are doing and how you are compliant or not with different regulation. Maybe another one that could be useful is implementation of blockchain. So I'll give different type of examples, so not only one that it's for Dupont, but a very I would say known one is the Wine Association in Italy. You know, they were encountering they were actually, their fake products were about 40% in Asia, especially in China. So imagine how many losses they were having. Now, by adding a blockchain network with a label that was very hard to on their bottle, and put on top of this very nice application that would be able to give you the overview about that product. Is it genuine or not? They even put data like from where those grapes were being actually harvested and when it was produced, wine, etc. They were able to reduce this counterfeiting with over 30%. And the same you could see here, that it's a long supply chain. And by adding in this blockchain network all your supply chain, you are able to dramatically reduce the losses. And believe me, for every company, I strongly believe that there are opportunities in millions, especially in different regions where counterfeiting may be higher or less. So you can see here different type of examples of how you can unleash digital, either by using AI machine learning for predictive maintenance, for predictive quality, either, for instance, by using to reduce your energy consumption, your chemical consumption, or by using blockchain, you know, to become more efficient and reduce the counterfeiting. There are a lot of opportunities for sure, and I think what every company needs to do is to focus on this journey to move from doing digital. And I see a lot of companies doing some RPA, Power Apps. And again, those are so it still helps you to create efficiency or productivity. But if you really want to unleash the power of digital, and how we are saying in Dupont, move from doing digital to actually being digital, you have to actually move along this chain and try to define for your company what being digital means and what type of digital products you can develop. And those digital products can be internal oriented, like some of the use cases I share here. You can also have products that are external oriented, and we're having platforms, for instance, for our customers that are able to help them understand much better how our solutions are working and how to reduce their operational expense. So try to understand not only doing bits and pieces of digital, but have this as a holistic, I would say, approach, where different type of technologies, but all of those will give you actually the entire universe of unleashing digital in your area or in your company. And I'll stop here to give as well time for some questions. I hope I was in time.
Cristian, you were perfectly in time. So actually, I think we have time for 2 questions. So the first one's coming from the audience and from Srikola from University of Luxembourg. It's a bit technical, but if you can see it in the Q&A section. So what kind of issues do you encounter interacting with AR systems?
Look, there is no perfect digital system, right? So the biggest problem is initially was to map basically the plant, for instance, right, with the videos and try to see how accurate it is. Now, there are sometimes issues in mapping this. I would say the biggest problem is mapping initially. After, I have not seen so big issues, mainly in the training of the people. Once they get trained, honestly, we haven't seen that many issues.
What is the biggest driver to go through a digital transformation journey?
Well, I would say there are several. So couple of months ago, I shared with our board one nice video where the CEO of General Motors was saying the revenue that we generate today from selling cars, we envision that in the next 5 to 10 years, we're going to generate from the software attached to the cars. So think about how ambitious they are and their vision. And this is actually what we are looking as well at Dupont. I have a full software team that I've developed and that is helping us to do not only the use cases that you see here, but as well much more looking in developing software for our customers. From the moment they select what is the best solution for their plant till the moment they operate those by using our solution, moving actually from being just a hardware provider or a software or a service provider to become a more of a software company, it's actually the biggest driver. And as the mentioning, the fact that you would be able in the coming years to generate the same revenue as you do today from this, it's actually something amazing, I would say.
Okay. Thank you very much, Cristian. There are 2 other questions waiting for you in the Q&A section, so you can directly reply to the audience. Thank you very much.
Thank you. Have a good day.
Thank you, Cristian. We now move to the second presentation proposed to you by Mr. Mark Offenburger, ILS manager at Avery Dennison. He will detail the intralogistics challenge and production online monitoring. Over to you, Mr. Offenburger.
Okay, thank you, Anthony. Thank you, Caroline. And thank you to Lux Innovation for inviting me to speak here. I'm going to share my screen. There we go. So I'm speaking today about the plant intralogistics challenge. But before I talk about that, just like to say a few words about who we are, Avery Dennison. We are a Fortune 500 company. We have $4.7 billion US in revenue in 2020. Roughly 2/3 of that overall revenue resides in the label and graphics material business. And there's many plants around the world in this business. One of them is in Rodange, Luxembourg. That's our plant, Avery Dennison. In Rodange, we produce over 2 billion liters of pressure-sensitive materials per year. We do that with 500 employees, with lots of different nationalities. We have 4 big coating units, coating and laminating units. 3 of them are 2 meter wide, 1 is 1 meter wide. We have 13 slitting machines, 4 packaging lines, and all of this within a factory of 67,000 square meters. So that's a little bit about us. But to talk about the intralogistics flow, I thought I'd give you just a brief flow map of our plant with some numbers. So we receive our raw material, as you see in this photo here, on trucks to the tune of 600 to 800 rolls per day. Those rolls are then put directly into our automated warehouse. We have in this warehouse between 1,500 and 1,800 movements per day as well. Then when we need to take the raw material out to send to our coating operation, we do that to the tune of about 780 rolls per day to the coder and then back from the coder to the warehouse. The warehouse has a storage capacity of about 77,700 rolls inside. And then finally, when the customer order comes in, we take the work in progress out of the warehouse again, send it to our finishing line. We cut it to the length and the width the customer needs, and then put it on pallets and package it. So that's a brief overview. I'm going to try to give you a virtual logistics tour of our plant with some video that I took last week. So the quality is not perfect, but you can see here. The video on the left-hand side is the fork truck that is unloading the trucks, materials from the trucks themselves. He places the material in a bin. The operator then scans the bin, the barcode on the bin and on the roll. That calls the shuttle, which you see in the video on the right, to come and fetch the roll and bring it from the bin to the warehouse unit. The receiving area, there's 2 main bays that we see here. The receiving runs 24 hours a day, 5 days a week, I should say. And yeah, there's quite a bit of activity in that unit. Then we move on to the warehouse. We have, I've got 2 videos here showing the operation of the warehouse. The video on the left, you can see the trolley, which picks up, places it into its in front of the trolley. You see a couple of shuttles going to fetch some other rolls to bring into the warehouse. The video on the right is, again, same view, different rack, but the same type of view. So you have different views. In our warehouse, we have 5 racks similar to the 2 you see in these 2 videos. So it's quite a large operation. all of our raw material is put into the warehouse before it goes to any of our production units. And then we move on to coding. So now coding, when the operator is ready to produce his product, he goes into our ERP system. He chooses the material that he needs to feed to his coder. The warehouse then is move the roll or take the roll out of the warehouse that he needs to place it on a presentation stand for the automated guided vehicle, which you see in the video on the left. The AGV will then pick up the roll and deliver it, the video on the right, to the coding unit itself. So it's important to note that all of this is fully transparent for the operator. He simply clicks on the button or on the roll that he needs, and the system takes care of the rest. Delivers the roll to him as he needs it, when he needs it. Then after the coding operation, we send the material back to the warehouse. So again, you see the visualization of the warehouse. Video on the right is taking the coded roll out of from the coding unit itself and dropping it off into the warehouse. The video on the left of the corridor between our two main coding operation assets, Lux 1 on the right-hand side and Lux 2 on the left-hand side. The majority of the traffic of the AGV resides in this corridor, at least for the delivery to and from our coding units. And so you can see that there's quite a bit of AGV traffic in this zone. You'll notice that there's some floor markings that I'll talk about in a little bit as well. So once the coded material is in the warehouse, as the customer order comes in for the finished goods, the slitter operator then calls the material that he needs to cut in length and width. And once again, he selects that from the ERP system, the warehouse AGV system, then delivers the roll to a presentation stand in front of the slitter. That's the video on the left, which is having a hard time to play. This is being delivered in front of the slitter 17 in this case. The operator will then take it from the presentation roll, put it on his machine, cut the material as needed. Any material that's left over, he'll put back on the presentation stand, and the video on the right is simply the AGV unit will pick up the roll and place it back into the warehouse where it gets stored for its next use. And then, of course, the final step is just packaging, putting on pallets, and sending to our shipping department. So no video here, just some photos. So a few words on the intralogistics operating systems. First of all, the system itself combines the different systems that are independent. So the warehouse is one supplier, the AGV units is another supplier. So the operating system we have puts all of this together in the spirit of Industry 4.0. You can see here the receiving bins, 2 bays of the receiving bins. We have visibility of what bins are being used, as well as what shuttles are carrying what product, the product code that's on the shuttle. We have the visibility of all the elements within the warehouse, as well as which is actively moving right now and what has product on the shuttle itself. We have visibility also for the stands in front of our 2 main 2-meter coders. And likewise on our finishing park, we see the visibility on the stands just before. And finally, we also have the visibility of our AGVs. We can see what the status is, whether they're full or empty, and what material they have that they're carrying if they're full. So we made a lot of investment in Avery Dennison on this automated intralogistics system. I guess the question is, why did we do it? So what are the advantages? The first advantage, and by far the greatest advantage we have, is in plant safety. You can imagine that with thousands of rolls being transported in the factory, that does represent a risk in terms of material flow. For the AGVs, they are all pre-programmed routes, so they're very predictable. We know where they're going to go. It allows us to have very visual zones. You can see the floor painting that's in yellow, which indicates where the AGV will run. They won't go outside of this yellow zone. It allows us to put in pedestrian walkways that allows us to separate the pedestrians from the AGVs, again increasing safety. And each of these AGVs has a detector in front of it, so we can detect if there's obstacles, whether it's human or objects. So safety by far is the biggest advantage. There are other advantages, of course, as well. The fully integrated warehouse and automated guided vehicle system. This is, we don't have to call out the material from the warehouse separately from having the AGV, telling the AGV to go pick up that material and send it to some other location. It's all integrated into one system. So you click on the ERP system, what material you need, and it gets delivered. With the system, we also have plant-wide visibility on constraints. You can imagine with the amount of flow that we have in our plant, constraints is a big concern for us. And so we want to have real-time visibility as soon as possible when there's a pinch point or a problem. Next, all of the AGVs are battery electric powered. They're all self-managed, so they self-dock to charge up if they need to have charge, and they will take missions only when they have enough charge to be able to take the mission. As I mentioned before, it's integrated within the plant ERP system. You might be surprised to know that this was first implemented in 2004, so it's not a new system. However, in the early days, it was very simple, much smaller operation. The routes were very simple and very direct. We have since made extensive capacity increases within the plant, and one major investment in 2017 in assets, but also in AGVs. We increased a lot of AGVs and more than double the size of our warehouse. And importantly, we put in a major upgrade from the operating system itself, which really allowed us to go into further improvements, which is what we're actively working on now, such as each of the warehouse key elements are integrated into the automated reporting system. So we can get tracking on efficiency, downtime, percent usage reports of each of these warehouse elements to allow us to optimize everything. Likewise, we have a dashboard for AGV status and actually roll status. So as the roll is deposited on a stand, we have a timestamp, and we track whether any of our rolls are stagnant for too long, and it indicates where we have a problem with our overall plant flow. Third thing we've put in place is mission prioritization improvements. We use geolocalization of the AGVs. An AGV will not take a mission that's on the other side of the factory. It'll leave that to another AGV over there and take the mission that's most appropriate for where it is. And this is just changes in the logic. And in that same theme, we are actively working on route optimization algorithms using the AGV analytics based on the information we've got on the AGVs, the efficiency, the amount of kilometers run by the AGV, the percent load versus unload time with the AGV, and all this based on the logic rules that we have. We can optimize each of those different indicators. Likewise, we have optimized roll location in the warehouse. We're working on this as well. As rolls come in, statistically, we know where they're going to be used in our process, and so we will place those rolls closer to where out of the warehouse. And finally, we're also working on kind of an intelligent self-organizing warehouse. So in periods when we're in low production or on the weekends, the warehouse can strategically reorganize itself based on the planning that it knows in advance of what material is going to be coming out the next few days, and place those materials at an appropriate exit point. So these are some of the things we're doing in line with the overall vision. We've got a very strong background foundation in Avery Dennison in Lean and Six Sigma, and we do a lot of work in those areas. We are rapidly moving on to advanced analytics, where we're using predictive. We're using lots of data to get some predictive modeling, whether it's logistics systems or other assets as well, and then of course going into machine learning. So that's it for me. I may have taken. Don't know how we're doing on time, but if you have any questions, please don't hesitate.
Thank you very much, Mark. No, you are perfectly on time. So there are not so much questions for you in the Q&A, but I have myself some questions. And first of all, thank you very much. I visited your warehouse a couple of years ago, and I was really impressed by the investments into the intralogistics and the smart, I would say, technologies and processes that you have implemented in Rodange. So really, congratulations. You were speaking about safety. That is really, I would say, a key problem or a major issue to face. What safeguards do you have concerning machine or a system shutdown, for instance?
So we have full redundancy on our server. So if there is a bit of buffer with our logistics system, so we do have a bit of time to deliver material to our assets. So with backups on servers and backups on our units, each AGV can run individually and do not need the other AGVs to be running. The warehouse itself is split into numerous different racks, so a rack can be down and the 4 other racks will be working fully independent.
Mhm.
And again, backup servers is what we use to maintain all of it.
Okay. And maybe another questions about maybe capacity constraints that you would have with your logistics systems. Do you have some? And if so, how do you address this?
Yeah, I mean, that's the main concern we have. You know, we've been growing every year since we put the system in place in 2004. We've been growing every year at 2, 3, 4% and making investments. And so the system we've found, which was well oversized back in 2004 when we had it, is now becoming one of the critical elements of a pinch point. So we need to make further improvements. And the way to make further improvements by adding more machines, you lose efficiency and all that. So you need to have much better visibility on the data you have. You need to have sufficient analysis on the logic patterns that you put in place for the AGVs, so that they can, of course, operate in the most efficient way possible. So yeah, it's a major concern. Clearly, where one of our main investigations are going in terms of big data.
Okay, thanks a lot, Mark. I think we'll stop now for the questions, but now there are 3 or 2 questions for you in the Q&A tab. So it would be nice if you can answer directly to the people in the Q&A tab. And I thank you very much for your presentation.
Sure.
Okay, thank you, Mark. Now I'm pleased to welcome Mr. Roberto De Gori, IT Manager at Ampacet. Mr. De Gori will explain the benefit of the digital transformation on manufacturing and intralogistics. Mr. De Gori, the floor is yours, please.
Okay, thank you, Anthony, and thank you everybody for attending this webinar. Today, I will present a use case of digital transformation on manufacturing and intralogistics at Ampacet. Maybe some of you already know Ampacet, but I give you anyway some general information about the company. It's a privately held company present on the 5 continents and established more than 80 years ago in New York. And it's a global master batch leader. I don't know if all of you know what is master batch. It is a kind of plastic pellets you can see in the picture. These pellets contain concentrated amounts of additives and colorants and are used at the end by other companies to produce plastic-based goods. And here you have some examples of these plastic-based goods. I mean, we produce master batch for the food and beverage industry, household appliances, industrial, personal care, agriculture silos, pharma and medical devices, and also construction material like cables, films, etc. This company, Ampacet, has 25 production sites around the globe, 30 strategic distribution locations, 4 research and development centers worldwide, and it's organized in 4 regions: North America, South America, Asia Pacific, and Europe, Middle East, and Africa. And we have more than 2,200 employees, and our production capacity is over 440,000 tons a year. Regarding our presence in Luxembourg, well, we are based in Dudelange, and here at Dudelange we have the headquarters for the EMEA region. So all back office departments like IT are based in Dudelange. We also have here a manufacturing plant and an European distribution center located at the Aero Hub. And we also have our R&D center and a color center of excellence. From Dudelange, we manage all regional plants. I mean, Mesancy Belgium, Telford in the UK, also in Poland, Ber in Russia, Dubai, and the new plant in Brembate, Italy. In Dudelange, we have more than 200 employees and more than 500 at a regional level. Regarding the project I'm presenting today is the construction of a new plant in Brembate, Italy. Brembate is a small town in the north of Italy, very close to Bergamo and Milano. And this plant was the main project for Europe this year. And in fact, almost the entire IT team was exclusively dedicated to this project. As you can see on the right picture, it's a very, very big area. The total surface area is more than 75,000 square meters, and half of that area is covered. The objectives of the project was to build a new plant in a warehouse in Brembate in order to improve our manufacturing capacity in Europe. A second objective was to relocate other lines from current plants in Italy to Brembate. And regarding the IT side, I could say the objective were to get a full automation of lines and warehouse and set the foundation of new processes to be replicated in due launch next year. Regarding benefits, the expected benefit was to satisfy an increasing market demand on master batch and to reduce the time to market for the new goods as requested by our customers. And again, regarding the IT the department, the expected benefit was to have a paperless operation and to meet the latest Industry 4.0 standards. Here you have some pictures. Well, on the left, you see, well, the entrance and an alley that can show you how big is the place. In the center, you have two pictures about our manufacturing lines. And on the right hand, I don't know if you see the one on the top, but this was our warehouse, the HEB solution. Now we will present the IT side of the project. I mean, the digital transformation of manufacturing and logistics, and you will find some similarities with the previous presentation. So thanks, Mark. You made my presentation easier today. As every project, we divided the project in 3 phases. The phase 1 was mostly focused on improving our ERP. The ERP is our core software that supports our entire operation. So as always, we took some existing processes that were working well, and we replicated those processes in Brembate. But on top of that, we created new processes and we redesigned some existing processes, especially those related to the warehouse management for raw material and finished goods, and also the work order management automation. I will explain it in some minutes. But it was not only about improving our ERP. We integrated our ERP with different third-party software. And on top of that, we delivered a mobile solution in order to automate some of the tasks done before manually by the operators, like receiving raw materials, like picking the raw materials and loading into the feeders, like moving pallets or bags from the shop floor to the warehouse, to do the finished good declaration, the quality control, and finally to get the materials, the finished goods from the warehouse to be shipped. Our phase 2 was mostly concentrated in the new warehouse manager, the warehouse software manager, and especially because it was a new solution for us. No more forklift drivers. We implemented an HEB solution as Mark described before. So now we manage our warehouse by giving software instructions every time we need to put something into the warehouse or to pick for the shipping. And we will have a phase 3 next year, mostly related to maintenance. We will try to automate the entire work orders related to maintenance, and we will also implement IoT solutions. By IoT, I mean Internet of Things, in this case, sensors, in order to capture some variables like humidity, temperature, and running hours for a specific machine. And finally, next year, we should be able to replicate the new solution delivered for Brembate in due launch. That's the last goal of our project. So here you have a digitization flow from the raw material receiving through the finished goods shipping. So you will see here some points in orange that's related to the mobile solution we delivered, and you will also find some mentions highlighted in blue, and that's regarding our integration between the ERP and other softwares. Well, as you can see, we will start by using a scanner similar to the one in the picture, and we will have and we already have a screen in order to do the receiving and to move the pallets we receive to the warehouse. And afterwards, we will have another mobile solution to pick those raw materials and to load it into the feeder. In case we have bulk receptions, we have an integration between our ERP and a silo management SCADA software. So in that case, the raw material will be directly put in the silo, and it will inform our ERP. At the end, we will have an integration between our ERP and the manufacturing line SCADA. Okay, in this case, I will explain afterward more details. Once we have the finished good, we will have another mobile screen to do the finished good declaration and the quality control, and to move those finished goods to the warehouse. We will have the last integration with the new warehouse solution, and at the end, a mobile screen to select, to choose, pick from the warehouse and prepare to ship. Just to give you some more details about the integration between our core software, the ERP, and the third-party software, one of the important integration is related to the manufacturing lines. We have now an SCADA. So before, we were just inserting manually the data from the ERP into the SCADA, and now the SCADA received the production schedule, including the part list from the ERP. And once the production is done, I mean, at the moment of the shop closeout, the SCADA informed the ERP the real consumptions of raw material and also the production hours involved. So now we have a full automation regarding the manufacturing lines. We have also an integration, as I said before, with another SCADA software for silo management. So now the SCADA managing the silos informs the ERP when receiving raw material, and the ERP dialogue with the new solution when it needs to transfer the raw material to the line feeders. And finally, the integration with the warehouse management solution. We have, as Mark explained, a new generation warehouse with HGV, I mean automated guided vehicles. So there is no need now of forklift driver inside the warehouse, and now the SCADA software managing the warehouse is in dialogue with ERP. Every time the finished good need to be stored in the warehouse or to pick up for shipping. So for us, it's a kind of black box. We just give them software instructions to move the forklift inside the warehouse. And additionally, this SCADA software offer artificial intelligence. They applied AI to better place the pallets in the warehouse according to the shipping frequency. Well, I don't have the time to explain the technology behind this integration, but it's not too complicated. It's a REST API solution using microservices. Maybe some of you heard about this. I also mentioned another part of the digital transformation, and it is related to the mobile applications. So as I said before, we use this kind of scanners to read barcodes, QR code, etc., and to make it easier for operators to receive the raw materials, I mean the pallets and the bags, to move raw materials or finished goods from one location to another, to do the quality control and the picking from the warehouse. So which kind of technology we have behind this solution? Well, it's not actually a mobile app that you can download from the App Store or the Play Store. It's just a web browser running on these cell phones and calling ERP screens. So now we are using the same screen we use in a desktop PC or in a laptop in the new guns or scanners you can see in this picture. This project, I mean, the first two phases of the project are already done, but of course we have still some challenges to address. One of them is to continue with the change management initiatives, because you can imagine the impact the new digitization and automation had on the culture and the organizational culture. So now, people need to interact in every process with technology. Just to give you a clear example, when dealing with HEB in the warehouse, there is no forklift driver to talk to and to give orders in case of a problem. We need always to interact with the warehouse HEB by software instructions. And now we can say this project was a success. And so the C-level is pushing to raise the bar. And we have a lot of initiative planned for the next years. One example is we were requested to automate the forklift guiding also in the shop floor. As a conclusion, I can say that this is a use case of how the IT can influence or drive the operational changes through the implementation of technology. And it was, of course, a kind of combo project, right? Because it was not just about implementing a software solution. It was technology and also business process management. I mean, improving existing process or doing an actual re-engineering. And of course, on top of that, we had to drive the internal culture change. And finally, what I'm most proud of is this project was a source of motivation for our resources, because the IT guys, we are used to make it happen, but it's not easy for us to see the result of our efforts. I mean, we usually deliver abstract solution. And in this case, for the Ampacet project, it was very concrete. We can see now how the manufacturing lines are starting and working, and we can also see how the forklifts are dancing in the warehouse just by giving them some software instructions. So, well, I hope I'm on time and I can answer to some questions if we have any.
Thanks a lot, Roberto. So you're perfectly on time. And I wanted to ask the questions of the challenges that you faced. But there is another person asking question in the question tab. So first is, what was the time frame to move from phase 1 to phase 3?
Okay, well, I could say that in order to address the phase 1 of the project and the phase 2, it took 10 months. Okay. So yeah, we started at the beginning of the year, and we delivered the solution by the end of October. Okay, and I think you explained well the challenges that you're still waiting for, or that are going to come, and the challenges that you faced. So I think it's okay now. And I see another question. Yes, maybe last question from Johannes Knier. Do you have issues with the data connectivity of your periphericals and not really issues, because the vendor for the HEB solution, they anticipated the need of a specific network to address all the devices in the warehouse. So it was not an issue, but we had to buy a specific solution for the warehouse, not the same as we have in the rest of the plant. Okay. Thank you very much, Roberto. It's really, really interesting. And I'm really looking forward to see this new plant arising in Luxembourg after it. Sure. You will be welcome. Thank you.
Thank you from my side as well, Roberto. So now it's not a science fiction, but you will now discover how collaboration between a human and a robot can boost productivity. I'm glad to welcome Professor Olga Rose from the University of Luxembourg. Olga, please, the floor is yours.
Yeah, many thanks for the kind introduction. I will just share my slides. Oops. Sorry, can you see the slides?
Yes, we can see them.
We can see the first slide.
Okay,
yes.
many
you can go ahead.
Yeah, this is, as you can see, a collaboration project between the university, or more specifically the SNT, that means the Interdisciplinary Center for Security, Reliability and Trust at the University of Luxembourg, and my research group, the Automation and Robotics Research Group, and Rotarex. Perhaps most of you know Rotarex is one of the world-leading producers of gas solution. That means gas solution means, as you can see here, these are these valves and fittings and all of these things which belong to the gas bottles. Very, very important. For instance, also in the current crisis, that means they also use, or you can also use these devices or the oxygen bottles, which had been very important, especially in the COVID crisis. Yeah. And here in this collaborative project, we were having a look at how to boost the productivity of Rotarex producing these devices using humans and robots and making them collaborating. And perhaps first, let's have a look at the challenges of the robotic assembly at Rotarex. That means, as you can imagine, they have the problem of, let's call it mass customization. That means they have many, many product variants and very small batch sizes. That means I think they have more than 200 product variants, and among those, a lot of sub-variants. And if they produce it, sometimes it's just in the range of a few hundreds of them, which means if you would like to do the assembly or also the production with robots, you have to be very, very flexible. And that's also the reason why, at least currently, mainly throughout the assembly especially, Rotarex is still using manual assembly, and that's what this project is about, how to finally at the end achieve a higher degree of automation. This is quite challenging. That means not that much for humans, but for robots. The question is why. You can see here, first of all, these parts are small, very small sometimes, and they are made of different materials. That means some parts are metals, others are rubber. And in general, you could say these valves, for instance, they look simple, but they consist of up to 100 of these parts. That means finally at the end, you can imagine this is a very, very complex assembly. Overall assembly, also the single assembly steps are indeed also very complex. On the other side, of course, you would like to have a high speed. That means assemble all of these things as quick as possible, but at the same time also with a high precision, with a high accuracy. And that brought us also to the question of which step perhaps is better done by humans and which steps are better done by robots. Now, here you can see there are already some first tests, you could say, where these small collaborative robots are used. But of course, there are still some steps, and even in the future, there will steps remain, which are then even better done by humans. And therefore, the question here is not to replace everything by robots, but really to have a human-robot interaction and a kind of real collaboration between humans and robots. For instance, by having humans bringing a pallet to the robot detects that, starting to do its own sub-assembly steps, and perhaps at the end to delivering a pallet of assembled or sub-assembled products to humans again back. And however, you can imagine a company like Rotarex, which is highly focusing on the production and also the design of these special products. They have an automation department, but of course they are not all very much specialized in robotics and robotics programming and so on. That means one part here also of our collaboration is about, let's call it the robot systems engineering. That means you can imagine if you would like now to change from one product to another one, the classical approach would be to always have a new robot set up and also a new programming. And that was also one of the big ideas here in this project, how to allow a process engineer, not a robotic expert, how to allow a process engineer to develop such a solution, such a robotic solution, and how to do the programming then as quick as possible and as efficient as possible. So therefore, the approach is here the development of a robotic systems engineering approach supported by machine learning. That means the idea is not going into classical programming. Nevertheless, we call it a programming toolbox. But I would say the hard coding, the traditional hard coding kind of programming should be as much as possible supported by machine learning to allow also a process engineer to do it. Yeah. So here you see, of course, such a robotic system, in order to be very, very, has different one very, very big part is the sensing system. Here in this case, we will use a vision system. And examples of these tasks that the vision system is facing is, for instance, which part to pick, where to pick. That means you also need to see or to sense the grasping points for the robots. And again, then talking about how can this be supported by machine learning? Yeah. So first, it's a decision which kind of sensors are we using. Here we decided to go into vision, because it turned out that vision is quite flexible here for the task, and then applying the machine learning in order to enable the system to see these parts as good as possible, and also to determine the pose, that means the localization, and also the detection of the orientation of these parts. On the other side, you can imagine you have the programming of the assembly tasks, and also the planning. So here we see two steps that we both will, to a certain extent, also solve with machine learning. The first is the overall assembly task planning. I think you can imagine that you have different parts that have to be put together, and of course, like an IKEA furniture, and I think it is a good example. You have to put these parts together in the right sequence. Otherwise, you end up with a huge mess. And the question here was, okay, how can we tell the robot about the sequence of how to do that? Yeah, really without going into hard-coded programming. And one possibility to do that, which again uses machine learning, is learning from demonstration. That means the idea here is you have the process engineer. The process engineer knows, of course, how to put the things together in the right sequence. Yeah, and he is simply, to a certain extent, the robot, and the robot is learning how to do that. And then finally, at the end, of course, you have the real robot motion planning. That means if you know then in which sequence to pick parts and to put them together, of course, also that has to be done as quick as possible, as we learned before, and as precise as possible. Yeah, here, first, let's have a quick look at this vision system. And here we will apply deep learning, or we are already doing that. And of course, now the question again is, if you would like to learn seeing parts, and indeed here we are talking about from a computer vision point of view, very challenging parts. Here some of the most challenging parts are these shiny metal parts. And then the question was, okay, how to do this in the easiest possible way. Yeah. And first it was also about the right selection of the most suitable sensor. And what we found was that indeed a vision sensor seems to be the best. First of all, they are not too expensive. On the other side, they can also handle, like you see here, shiny parts. Yeah. But the big question then finally at the end was, okay, in order to teach, or in order to have the vision system to learn, how to produce all of the scenarios, all of these different attitudes of these parts that the vision system finally should learn in the best possible way, without, again, having a human doing all of these demonstrations or programming it, in the worst case, hard-coded. And what we are doing here is that we have an automatic creation of a wide range of synthetic images. That means, as you can see here in the middle, first it's based on that the company like Rotarex, of course, they have cut models of all of these parts. And with the help of some latest state-of-the-art computer vision tools, you can create very, very photorealistic simulated objects. And of course, then you can present, you generate then thousands of these images under different in different positions, under different orientations and so on. And then you can, of course, easily, because they are created in the computer, you can easily present this then to the learning algorithm. And then finally, at the end, making this available to the sensing system and, of course, also to the robot. On the other side, there's the learning of the assembly task and also the motion planning, again, supported via machine learning. That means on one side now, what we are solving here with the deep learning is the vision part. But now if the robot is able to see the different parts, now the question is how to also learn the different assembly sequences. As I said, what we are applying here is learning from demonstration. That means, and this can be done in different ways. We are using here a kind of combination. That means you can, for instance, demonstrate something really live with the robot. You can somehow teach in the robot. You can also present certain steps in the computer. And what we are doing here, we are just combining all of these tools together. Then we are learning also then the sequences of the different subtasks, like, for instance, pick object X, insert O-ring, etc. That means it's really crucial, of course, to learn the right sequence. And one I would say overall novelty also is even in that to integrate human collaboration. That means, for instance, even in one of these sub-assembly tasks, it could be that two parts are put together with a robot, and then a human even also inserts a part. And this is also something that can be learned. That means in such a sequence, some of these sub-steps can be done also by a human. Of course, has to learn when to stop, and to let the human doing it. And then coming down, of course, now we are talking about the sequence. And now in order to really move the robot, you have to be, you have to do two things in parallel. You have to be quick and you have to be very precise. And of course, at the other side here, we would like to learn that. And there we are using so-called dynamical movement primitives. You can say kind of pre-configured, but nevertheless, they can be very complex motion primitives that you can then adapt again by learning. And in order to be then as precise as possible, you can then further improve that by what we call reinforcement learning. That means it's a bit like learning by doing. That means the robot itself adapts itself and becomes more accurate, you could say. So I would say that's mainly the big picture of the project. The project has currently started based on a lot of our previous experience with robots and with learning. And perhaps in one of the next smart manufacturing weeks, we can then also present about the outcomes. Many thanks, and I'm looking forward to the questions.
Many thanks, Professor Voss. It was really, really interesting. So there is already one question from our counterpart, Mark Offenburger. Does the human-robot interaction require rethinking or redesigning of the final product to make it easier or more effective for the robotic system to see?
I would say that's really a good question. I think it even goes a bit beyond the project here. So here in the project, I would say the product and therefore then also the sequence, how to put it together, is somehow fixed. But for sure, if you then see with outcomes, what parts are better done by humans and what parts are better done by robots, that might perhaps even change then the design of the products and designing the products then finally in a way that they are more being efficient to solve with this kind of hybrid human-robot systems. That might be indeed an outcome for the future.
And another question, but before, it would be better if you can stop sharing your screen so that the audience can see us better. Thank you. And I had another question about the collaboration. At Lux Innovation, we promote collaborations between companies and research centers and universities. So you partnered with Rotarex. So how did it happen? How did it go? What are the benefits? Can you give us some words about the collaboration?
Yeah, perhaps you know that the university, but especially also the S&T, has a partnership program. That means we are already collaborating with many industrial partners. And here we were indeed somehow brought together. I think it was even by Lux Innovation where we were brought together. And now we are also, of course, then using other schemes like the FNR funding. Yeah? And indeed, now one of our first PhDs working on that now just recently got a grant financed by FNR. And I think this is also something perhaps that will be explained now in one of the last talks here. That means in these collaborations, of course, you can let's say use the support coming from the company, but in addition, of course, you can also then together go for third-party funding, which indeed is, I would say, very well provided here in Luxembourg by the FNR.
Thank you, Olga. We won't speak about the, I would say, FNR fundings in the sessions, but yesterday during the live session, we had Marco Valentini from the Ministry of the Economy who explained the fundings for the companies coming from the Ministry of the Economy. So for those who did not, could not attend the session yesterday afternoon, you can still watch the replay and understand what kind of funding schemes can be provided. But for sure, FNR can support also research projects, PhDs, postdocs, and that's really a good asset here in Luxembourg. Thanks a lot, Olga.
Thank you. Thank you.
Thank you, Caroline. We are slowly coming to the end with Mr. Giles Brandon, Managing Director at Intelligence Consultant. Mr. Brandon will say a few words about Fit for NMP and the opportunities for industry newcomers in Horizon Europe. Giles, please.
So thank you very much, and good afternoon to everyone. So I'm going to be making a short presentation, and it's specifically targeted at industry newcomers. So basically SMEs, large companies here in Luxembourg who perhaps have not really participated much in the past in Horizon 2020, but are perhaps interested now with the new program, Horizon Europe, to get involved. So, not knowing exactly my audience, I thought I'd better take the liberty to say a few words about what Horizon Europe is. So, basically, it's the EU's largest funding program for research and development. It started this year and it will carry on to 2027. And there's a budget of 95.5 billion euros. So, it's very big. It covers many areas of science and technology, but structured-wise, it's basically organized into these three pillars. Pillar 1, excellent science. Pillar 2, global challenges. Pillar 3, innovative Europe. And then there's a sort of horizontal program running underneath called widening, which is mainly targeted at EU 13 and countries sort of from Eastern Europe. Now, in this sort of figure, I've put a few stars, and basically with those stars, I'm trying to highlight the sub-programs which could be interesting for those of you who may be involved in manufacturing technologies, clean and circular industries, and or advanced materials. So in particular, if you look at Pillar 2 and you see the star, this is by Cluster 4, which is dealing with digital industry and space. That's the sub-program where you will probably find the most pertinent calls relevant to your interests. But I also encourage you to look at, for example, in Pillar 1, under Marie Skłodowska-Curie actions, there are also opportunities to get funding in those domains. Similarly, in Pillar 3, European Innovation Council, I'm sure many of the SMEs present, there's something called an EIC accelerator, and this is a very interesting scheme for highly innovative, high growth companies. So in really concrete terms, what sort of calls are going on that could be interesting for you? Now, I'm not going to go into exhaustive detail here because I believe Francisco Milo, who's the national contact point at Lux Innovation, I believe in his presentation he'll go into more detail about the course. But briefly just say, look, under Marie Skłodowska-Curie actions, there's a call called Staff Exchange. That will have a deadline on 9th of March. Then in this Pillar 2 Cluster 4, there are 2 destinations. Destination 1, dealing with all manner of calls in the area of that has a deadline at the 30th of March. Destination 2, dealing with sort of key strategic value chains for resilient industry, that also has a deadline at the end of March. And then for the EIC Accelerator, which is under Pillar 3, there are a series of deadlines in January, April, June, and October of next year. And many of those calls that are shown on this slide, there's budgets of the order of several hundred million euros. So I said right at the start, look, I'm really interested here about industry newcomers. So if you're an industry newcomer, and by that I mean a small, medium, or large company that's somehow involved in the development or utilization of manufacturing technologies, clean and circular industries, or advanced materials, if you're one of those and you didn't participate in Horizon 2020 in what was the sub-program NMBP, well, then for us, you're an industry newcomer. And if you'd like potentially support to be involved in Horizon Europe, well, we have the Fit for NMP support service here to help you. In the next slide, I'll say more about the support service, but just to say very quickly, this is a free service run by 10 partners, including Lux Innovation. So before getting into sort of practical details of the support we can offer, I just want to elaborate a little bit more about these 3 research topics which we're dealing with. And on this slide, I've basically got terms which the European Commission is using in its work programs. So in the area of manufacturing technologies, this is basically dealing with technologies for sustainable, flexible, responsive, resilient, etc. factories that are enabled by digitalization, artificial intelligence, data sharing, advanced robotics. In other words, basically many of the topics that have been spoken about already this morning and yesterday and no doubt tomorrow. But also our topics cover clean and circular industries. So if you're involved in any fields dealing with the decarbonization of energy, the usage of hydrogen, carbon dioxide capture, waste heat recovery, etc. These are also interesting topics for the Commission and for Fit for NMP. And then lastly, advanced materials is extremely broad. I mean, it can be basically any kind of material that's sustainable by design, has enhanced functionalities, and is applicable in industrial processes and consumer products. So what does this Fit for NMP service, free service, actually offer? Well, if you register with the service, we can promote your organization as a potential partner for Horizon Europe proposals. We're also organizing workshops, many of them online, with organizations that are very experienced in Horizon 2020 and Horizon Europe. For example, organizations such as CEA, VTT, Fraunhofer, etc. Indeed, in December, we'll be having an online workshop with CEA and involving many of the industry newcomers that we already had registered with the service. Other support we give, we provide training on grant proposal writing and the use of various European networking portals. We also provide access to expressions of interest from proposal coordinators who are looking for partners. Another thing which strategically can be very, very useful is we can provide opportunities to participate in important European partnerships, such as Made in Europe, that's the one dealing with smart manufacturing, Processes for Planets, which is the partnership dealing with sustainable industrial processes, Batteries for Europe partnership, and various others. And then lastly, we have a budget to provide travel grants that can enable industry newcomers to participate in EU conferences, networking, and brokerage events. So look, it's a brief overview about Fit for NMP. If anything I've just said is potentially of interest to you, I strongly encourage you to go to the website, www.fitfornmp.eu, register interest there. We'll then get back to you and ask you to fill out a registration form. Contact with me directly. You'll find my email address at the bottom of the following slide. So, Carolyn.
Giles, so thank you very much. Indeed, it's a very, very interesting program, and we should stimulate all newcomers to contact you and to join the European Consortium. So I have a question for you. So can you give any recent examples of proposal coordinators that are looking for partners?
Thank you for the question. Certainly. Look, very, very recently, there was a brokerage event organized by the European Partnership Processes for Planet. And during that brokerage event, there were something like 14 or 15 project coordinators who were pitching their ideas and looking for partners. And this was all in relation to the cluster 4 called Destination 1. So we've obtained details about their proposal pitches, and at this very moment, we're actually reviewing the members who are registered with us and seeing where there are matches. And we're right now at the point where we're getting back to these project coordinators and saying, look, here's this company, that company, etc. Is this a potential match from your perspective? And that's just one example. There's plenty of others that'll be coming in the next few months. So do not hesitate to share that with us, and we'll share as well with the, I would say, manufacturing community in Luxembourg, those opportunities to get in contact with potential partners. Thanks a lot, Giles. Yeah, thank you very much, Karen. Okay.
Thank you, Giles. We are now entering the last session, which will be covered by our new colleague, Francisco Melo, who is Advisor European R&D and Innovation Support. Francisco will guide us briefly through the European funding support available in the area of smart manufacturing. But before, we would like to kindly ask you to go back to the poll section and answer the 2 short questions. It's important for us to get your feedback related to this series of conference. Thanks in advance.
I have
Up to you, Francisco. Yeah.
Pardon. Sorry, I just wanted to read the 2 questions of the poll so that, you know, it's very important for us to know if you appreciate these sessions, if you knew the companies. So please, it's only 2 questions. Thanks for your reply. That's all. Thanks. Francisco, the floor is yours.
Okay, thank you very much. I believe you are seeing my screen now. So as Caroline and Anthony said, I'm the newest member of the R&D and Innovation Support team at Lux Innovation, and I'm very glad that I was offered this opportunity to have my debut on the Smart Manufacturing Week. So last 5 minutes of the morning to talk to you about the European funding support in the area of smart manufacturing. As you'll be able to see, I have some small overlapping with Giles and about Horizon Europe and funding opportunities, but I'll briefly spend my 5 minutes explaining you what we do at our European R&D and Innovation Support team, and also what are the European funding programs and relevant opportunities for the industry sector and for smart manufacturing. So what do we do? So in our team, generally, we help you in getting acquainted, getting started, getting involved in European level R&D projects. And our services basically range from help you refining your project idea, your project concept, all the way up to the successful submission of your proposal. Going through, of course, identifying relevant EU funding opportunities, identifying partners, and providing all sorts of technical support. Basically, what do we do here? So we answer you questions such as where you can get updated information about programs and calls, what programs are most suitable for you, where and how to find European partners, what are the legal and financial requirements, eligible costs, constraints on budget construction, etc. So in general, we help you in making sure that you find opportunities that are relevant for you, that fit your strategy, and of course R&D interests as well. To the second part of my presentation and to you funding programs and opportunities. So that's why I start overlapping a bit with Giles' presentation. So Horizon Europe, if not the largest, it's certainly one of the largest world programs funding research and innovation, research and development as well. So I brought this slide to show you that roughly 35% of the whole budget is to fund climate change related projects. As you know, the European Union has this overarching objective of reaching carbon neutrality by 2050. So most likely your project will have to directly or indirectly contribute to reaching these targets, okay? Not only European targets, but also worldwide targets in terms of carbon emissions, such as the Sustainable Development Goals, actively supported by the United Nations. Again, as Giles was showing, so Horizon Europe is basically structured into three pillars. The first one of them aiming at reinforcing and extending the excellence of EU science base. The second, global challenges and European industrial competitiveness, focusing on boosting key technologies and solutions underpinning EU policies, both overarching policies and sectoral policies, and also the Sustainable Development Goals. And the third pillar, Innovative Europe, focusing on stimulating market-creating breakthroughs, innovation uptake, competitiveness, and jobs. So within this, I would like to call up your attention to Pillar 2 and digital industry and space. That's where you most likely will find relevant topics for your projects at European level. Deconstructing this a bit in terms of what is and what is not relevant. So Pillar 1 in terms of topic is rather bottom up, which means that within the general requirements of the Horizon Europe, you have some flexibility to present a project idea. It can be in any area. It is often focused on lower TRL. TRL, for those that don't know, stands for technological readiness level, and the European has a standardized, let's say, scale from TRL 1 that goes from basic principles observed to TRL 9 that focuses on a system that is proven in an operational environment, okay? So this Pillar 1 focuses very often on lower TRL, and mostly it's a single applicant type of application, but not only, okay? Pillar 2, it's top down. You have thematic calls within different thematics or general thematics within each one of the clusters that I just presented in the slide before, goes from mid to high TRL. Finally, Pillar 3, it's rather also bottom up. You have some openness to propose the topic of your project in any area from low to high TRL, and here you have both consortia and individual companies. My last two slides to explain you a bit what's in for you. So in terms of, as you can see in the small figure on the right-hand side, in Pillar 2, we have 6 clusters. One of them focuses on digital industry and space, and specifically for industry and manufacturing, we would like to highlight call topics now open on either destinations 1 and 2. Destination 1 focused on climate neutral, circular and digitized production. and Destination 2 focused on increased autonomy in key strategic value chains for a resilient industry. Okay, these are open. Perhaps a bit late to start your own project, but still some openness to perhaps integrate ongoing consortia that are already working on specific projects. Please let me know whether you would be interested in that. And also I brought here EIC. EIC, as Giles told you, there's still EIC Accelerator open, but new both open funding and challenges that focus on specific market topics will be opening from the, I would say, end of the first quarter of 2022. And I believe this can also be very interesting to you. This European Innovation Council EIC under Pillar 3, okay? So this is perhaps my last and most important slide, which I didn't want to bother you with the whole range of possibilities, going in depth with them. I think that the main intention was to plant the seed of European funding with you. And in case you're interested, in case you're willing to know more, please do not hesitate to contact me back, and I'll be very glad to help you with whatever I can. So thank you very much for the opportunity once again, and over to you, Caroline or Anthony, again.
Thank you very much, Francisco. We're glad you joined our team. So I'm sorry, no much time for questions as we are already late in time, but please, if you have any questions, join Francisco. You have his contact details on the screen, and you can also find his detailed information into Lux Innovation's website.
Thank you. As you said, Caroline, we are running a little bit out of time, so we now need to conclude. If you have further questions, you can still contact the speaker through the networking session in the virtual lobby. Lux Innovation would like to thank all the participants, the speaker, and the organizing team, for their contribution to the success of this webinar. We would like to remind you that Lux Innovation is there to support companies on their innovation journey with a wide range of services. Most of you work in a highly competitive environment where changes occur at an accelerating pace. Innovation is essential to remain attractive and take your business to the next level. Therefore, you can rely on us to provide guidance, assistance, and facilitate major cooperation projects in partnership with research and technology organizations. For your information, the next session will take place this afternoon at 4 p.m., focusing on digital transformation for SMEs. It will be done in French. We hope you enjoy this session, and thank you all again for your time and being with us today. Hope to see you soon. Bye-bye.
Thank you very much. Thank you all the speakers and the audience. See you soon.
Yeah. Thank you, Caroline. Thank you, Anthony.
Thank you all.
Bye.
Bye.
Thank you all. It was a pleasure.
It was a pleasure for us too.